So let's get started here. On page 37, I'm just going to make sure I have my notes ready to go here. So what is tolerance? Right. In manufacturing, when things are produced, right, things will vary. Why? Right? There could be an operator error, faulty equipment. There are definitely limitations to the measuring device. It could be the temperature of the environment. You name it. There are many reasons why there is a certain amount of tolerance. And what is tolerance? Right? It's the range of acceptable measures. Right? It's also known as the measurement variation allowed, so that something is still acceptable for its intended purpose. This right here, in a nutshell, is what the definition of tolerance is. And so, for example, food, right? When you store it in your fridge, do anybody know what the temperature in your fridge should be? I didn't know either, but I know because I've researched it, looked it up, Googled it. 4 degrees Celsius is basically what your fridge should be. But your fridge isn't always 4 degrees Celsius. Zero would be freezing. Then you're getting close to zero would be a problem, right? Like if your fridge is 0, your milk would start to freeze or your water would start to freeze because it's so cold. So 4 degrees Celsius is actually ideal. But what happens when you go, my kids, they think it's a TV sometimes, right? They just open it and they just look at the fridge and it's like, what do I want, right? I'm sure you've been caught doing that too, right? All that cold air goes out, and obviously now the temperature in the fridge goes up. Right? So you should close the fridge door, and then the thermostat inside tells the compressor, okay, you got to start cooling this again, right? So technically, your fridge always varies. It goes probably between 3 and then probably 6 or 7, right? But there's some leeway, even though you say, hey, milk has to stay at 4. There's some leeway there, right? Sometimes it goes warmer, sometimes it'll go colder, and so it's still okay for it to go a little higher or a little lower, but we're aiming for 4, all right? So let's say a company assembles doors for houses, right? Here's the key. This is another way that this is how what you should model your explanations by. If a door is too small, right? If they make a door and it's too small, smaller than your frame, there's a large gap. And in this case, cold air would enter the home, right? Or warm air would escape. On the other hand, if the door would be too large, right, it would not fit inside the frame. Right? It would either not close properly or be very difficult to close or open the door. So what this is saying is, right, that there's a minimum and a maximum allowed measurement for many things, right? Like when you get your vaccines or your shots, right? I'm sure there's some leeway that it can be off by. Obviously, you want to go exactly if you can, but if you're off, I'm sure there's a little bit of a tolerance there. In certain industries, there's a big tolerance. Other industries, there's a very small tolerance, right? You can't mess up by a whole lot because then the consequences are significant, right? Tolerance would have to be between the two scenarios above, right? And so the difference between uncertainty and tolerance, because we've been talking a lot about, we found the precision, then we determined the uncertainty. And some students don't know, are they the same? How are they different? And here is I put them side by side. Uncertainty is determined by the measuring device, also known as the margin of error. And therefore, this is set by the measuring device. Your measuring device determines what the uncertainty is. Okay? However, tolerance It's set by the industry, right? The industry sets the tolerance. They determine, hey, this is acceptable, right? Based on what that item is going to be used for, okay? And why, again, why is this caused? Why has the industry, why do they have to account for some kind of allowance? Because of human error, equipment malfunction, and limitations to the measuring device. That is why the industry sets that. So there's basically a minimum. There's basically a minimum acceptable and a maximum acceptable measure, and everything in between is what we call acceptable. It can still be used for its intended purpose. So, for example, a pop can, 355 mLs, right? That's what it says on the can, but I can guarantee you that some will have less, some will have more. Did I weigh the granola bar with you? Did I weigh that with you guys when I used that scale? I returned the scale already from the chemistry teachers. A pencil? Okay. In a different class, I did a granola bar and said 46 grams, and then we weighed it, and it was 43 grams. So let's go sue them, right? No, I'm just, it's going to be off, like, and that's okay. There's always going to be a little bit of, there's going to be things that go wrong, and that's why tolerance is, there's a certain tolerance. But I'm sure that in the factory, when the granola bar weighs too little, like let's say something goes wrong and it weighs like 30 or 20 grams, I'm sure it gets discarded, right? I'm sure something kicks it off the assembly line or the line, right? Stating tolerance. This is the meat and potatoes of today's lesson, right? You need to know 4 things when it comes to tolerance: the maximum, minimum, nominal, and tolerance. Can we highlight nominal? Because that is important for you to know. What is nominal? It is the target value, right? That's what we're aiming for. That's what ideally you want every granola bar to be 46 grams if possible. In this case, right? That's the example we just talked about. And this is just to give you a visual that there's a max and the min, and the tolerance is the difference between them. Can you highlight this too? Tolerance is max minus min. And all of this in here is acceptable. Anything in between the max and the min is acceptable, and this is, right, discarded. And they make your shoes, right? I'm looking at shoes, right? It says size whatever, size 10. I can guarantee you that not all shoes are exactly the same, right? But there's some tolerance there because the machine, right, may be a little bit off or whatever, and it's okay. But it can't be off by too much because then people are going to start complaining, right? All right, let's do some math here. You're probably saying, what is going on here? I'm going to distill this for you. Tolerance can be expressed in 4 ways. Okay? And here they are. These are the 4 ways. So I'm actually going to highlight this chunk here. So there it is. Those are your 4 ways. I can tell you this. You are going to be able, or you should be able to go from one to the other to the other. You can rewrite it in any which way you want. And I will show you how to do that. Secret way. It took me, this is a painful unit, guys, for me too. And so I'm trying to make it as easy as possible for you guys. Okay, so watch this. I give you what it should look like, the template, and this is an actual example, right? So you're like, okay, this one has a number plus or minus. Which one of these has the plus or minus? It's this one, right? That's the only one, in fact. So this is modeling what what I just gave you here. And you should be able to, right off the bat, I'm going to use a different highlighter. The province has assured us that the big number up front is our target, is our nominal. So let's go ahead and put the 250 here. Boom. Okay. And now we're going to get our max, our min, and our tolerance. Watch this. How do we get our maximum? We go 250. We basically follow this. 250 plus, what's half of 10? I think we should do that right here. Half of 10 is 5, right? So basically 250 plus 5 is 255 milliliters. That's the greatest amount that is allowed in this case. If you want the minimum allowed contents, you would go 250, you go back to 250, and now you're going to go minus whatever follows it, minus 5. So that'll be 245 mLs. And now you find your tolerance. You can tell what the tolerance is by looking here, right? Because this is the lowest, this is the highest. What's the difference? 10, right? You can see 10. So I'm using this formula right here. Tolerance is max minus min. Okay, so I'm going to say max minus min just for this one. I'm going to show you that. And that's 10 mLs. Okay. Yeah.
Even though we're supposed to max and minus min, how come we can't just pick the 10 ml tolerance?
Yes, so that's a good question because sometimes this half is not in front of the bracket. Someone will have written 250 plus or minus 5 mLs, like they'll just have they will have gone half times 10. So in that case, it wouldn't be just that number that follows. But if you do see it in brackets, you can do it. I would say, from my experience, this is the fail-safe way of doing it. Go ahead. Let's do one more. Guys, this is so important. If you can wrap your head around what I'm doing, I'm breaking this down into these components. Because once you have these components, you can rewrite it in any other of the 3 forms. That is why I'm doing this exercise. Let's do one more. You look at this example, and it obviously is this one right here. Right? You have a number minus 0 plus a number on top. So it's this one here. Okay. What's the max? It's 5 plus 2. So that's 7 degrees Celsius. The min is 5 minus 0. Really, Mr. Erickson? You're going to go minus 0? Yeah, because sometimes it could be something other than a 0. So let's just go with it. Tolerance. What do you do for tolerance? Max minus min. And it is 2 degrees Celsius. And what's the nominal, you think? What's the target? The big number in the front. Okay, this one. This is going to be your nominal. Always, always. The big number up front is your target. Boom. You've got all 4 things, and this is crucial. One more. You've got a number, a big number, plus, minus. It's plus 0. So let's go to my study sheet. The plus 0 is this one, okay? So this one matches that one. Okay, so max is this plus that. That's just 45 millimeters. Min is this minus that. So 45 minus 1 is 44. Make sure you have units everywhere and do not round. Tolerance is going to be max minus min. And that's just 1 millimeter. What's the nominal? 45. Yeah, we're almost done. And then on the next page, I'll do one more. I'll show you how to rewrite it, and then I'm actually going to ask you to do one right away on your own. Okay. So here's the last one. This is a special one, right? You should recognize there are only two numbers. So you look at your 4, right, that you'll have on your study sheet, and the only one that it matches is this one. What does that mean? Well, the top number is your max, so just go ahead and fill that in. The bottom number is our min. That's our lowest possible value. And the tolerance, 15 minus 12, that's 3 centimeter. There's a 3 centimeter tolerance. And what's the nominal in this case? It's actually, it's the one, whatever is in between the average of the two. So the average of the two. So watch this. I'll put a star here. Nominal needs to be calculated. Needs to be calculated. This is the only one where that is the case. The only one. I'm going to zoom into that. So here's the formula. Nominal is max plus min divided by 2. I would box this in. This is finding the average, guys, right? When you find the average between two numbers, you add them up and divide it by 2. We'll do more of that in statistics later on this semester. So to find the nominal, we got to go 15 plus 12 over 2. What is that? You got to be careful. Watch what I'm going to do. I put these brackets there for a reason. I shouldn't have to put brackets, because if you have this, you should first perform this top part. So it's 15 plus 12, which is 27 divided by 2. And so what's half of 27? You were thinking divided by 3. Yeah, I know. It's all good. 13.5 is your answer for that one. So that's the only, this is the one where you don't have a nominal. The province told me that you will most likely not be asked to figure out the nominal if it's like this. But if you do, then this is how you would do it. We would assume that it's halfway between the two. That's what 13.5 is, if you think about it. It's halfway between the lowest and the highest. Okay? So that's a little bit of an aside. That's a special case. So I was just teaching you a skill here, and let's put it to the test. Let's use this skill that we've just learned. Let's go to the page 39 here. I'll do one, and then you'll do the next page. "39. When you're asked to rewrite a tolerance into other formats, you should try to determine the max, min, tolerance, and nominal." That's what I just made you do the whole time. Once you know these, you can simply follow the formats on your study sheet. Write the following, sorry, this is not right. Write the following, scratch this one. Write the following into the other 3 formats. So we're talking tolerance here. And which one of these 4, this is your study sheet, by the way, down right here. This should be on your study sheet. Which one of these 4 are you already given? This one, this one, this one, or this one? This one, right? This one looks like that one. So this is already checked. I don't need to rewrite it. It's already done. I need to rewrite it into the other 3 formats. So before you do anything, do this for fill in this thing right here. So let's do that. What's the max? Max is 45 plus what's half of 4? There we go. So 45 plus 2, that's 47. And minimum will be found by going 45 minus 2, and that's 43. Tolerance, yeah, I know some of you will say it's 4, I can tell, right? But I'm going max minus min, and that's 4 millimeters. And what's the nominal? 45. It's a big number up front. Right? I highlighted so you see it's like, okay, that's where you got it from. It's the big number up front, 45 millimeters. So this, I will not ask you to do this necessarily, but I would strongly suggest you do it before you rewrite. So basically you break down the information this gives you into these 4 pieces. Okay? All right, let's rewrite. Easy peasy, guys, easy. So this one calls for max and min stacked. So let's take our max, which is 47. And what's our min? 43. Now you wrote the tolerance in that format. Perfect. So where would you want to use this? Like when would someone want to use this tolerance? This is when it really doesn't matter how long that piece is that you're cutting. It doesn't matter. As long as it's anywhere between here, we're good. We're not really aiming for anything in particular. Just make sure it's in between here, right? So the nominal is not as important here. Let's do it this way now. What does it call for? Minimal, right? Minimum, which is 43 millimeters. It goes minus 0 here. And think about it, it doesn't go any lower. So yes, this is your minimum, but it is also your target. And then you go plus whatever your tolerance is, which we determined to be 4 millimeters. There we go. Now you have it in that format. And last but not least, max, which is 47. And you go plus 0 millimeters. So use whatever units you are given, right? Minus the tolerance. It calls for tolerance, so that's 4 millimeters. Fun stuff, eh? I like to give an example. When would somebody want to use this one? And I'm thinking of a landing strip for an airplane, right? You think of like, hey, it has to be like 2 kilometers. It cannot be shorter because that'd be a problem. It can be longer, like your strip can be longer if you want, but not shorter, right? So think of it that way. I would think this one here may be a good one for giving a dosage, right? Someone, you shouldn't be over. It's okay if you're below a little bit because it might not be as effective, but don't go over because that's dangerous, right? So then you might want to use this one. But we're always aiming for that big number up front, right? So in this case, we'd be aiming for that. Here, be aiming for that. Here, we would be aiming for that. So I took the one I was given. I determined it to be this format. It doesn't really matter, but you just go ahead and fill in this for yourselves. And then you bleed into the other ones, right? You kind of use that to rewrite, okay? Last thing here, and then you'll do page 40. This is something that I will ask you, the province will ask you. It says, which of the following strips would be acceptable? And here's what I want you to think of. You have the max, which is 47 millimeters for us, and the min, which is 43 millimeters. Anything in here is acceptable, right? Anything in here is acceptable. Anything outside of that is not acceptable. So 43.01, is that acceptable? Is that is just bigger than 43? That's somewhere in here. So that one is actually good. 47.01. This is the 47 line. 0.01 is just outside. Just outside. So this is actually not acceptable. Too large. Too big. 42.99. It's just under 43 right here. Also too small. So too big. Too small. 42.79. It's somewhere in here. It's even smaller. It's not acceptable. Too small. Okay. So the only piece that would be acceptable here is this one, because it 43.01 is just over 43. It's like right here. So anything that falls in here is fine, including the line itself. So if it had been exactly 43 or exactly 47, that would have been acceptable as well. Okay. So think about it this way. It can't be smaller than the lowest, right? And it cannot be bigger than the max, right? That's where it's at. Can you see that? It's too small. There. Yay. Focus. You should also have a focus button, right? Focus, focus. Sometimes you're probably thinking of, what am I going to have for supper? What am I going to do after school? All right. Did the 10, right? You ready? I just want you to right now do page 40. Don't go past 40. If you go past 40, you will not be in trouble. But anyways, don't go past 40. I just want you to try this page. I want everybody to have something on that piece of paper. If you get it wrong, what's going to happen if you get it wrong? Nothing. Absolutely nothing. You're just going to say, oh, that's how you do it. And then we're going to correct it, okay? So you try it, but you got to watch out. Okay. Consider this your last example before I let you do a few. I'm going to actually get you to do a few of these. So anyways, why are we doing this? Just to help us out when rewriting, okay guys? So the max is 110 plus 10. Just make sure for now you put your devices away, okay? I don't want you to have that. Don't tell yourself later it's like, oh, it's because of my phone that I didn't do so well, right? So when I'm teaching, just put it away. And then when you're done, like let's say you're completely done, I'm okay with you checking your phones, right? Even then I would say try to minimize it. Try to minimize phone time, guys. I'm serious. I'm talking to myself here too, right? First thing I do when I wake up, I check the weather, I check this, I check that. I'm like, just relax, right? Just start the day, have your coffee. Tolerance, 120 minus 110. That's 10 yards. Nominal, it's this one right here. Okay, which one am I given out of these? Sometimes it's kind of hard, but really just look at where the minus 0 is. This one has the minus 0, this one is given already. So I just need to do the other 3. So max min, you literally just stack them like this. However, make sure you have your units. Then this one, max is 120 plus 0 yards minus tolerance, which is 10 yards. Check. This one, bless you, 110 yards plus or minus half of your tolerance, right? Boom. That's what you should have. And if you were able to do that, you're in pretty good shape. That's basically how you rewrite tolerance, and they ask you to do that quite often. A question may ask you, hey, based on this tolerance, what's the maximum allowed here? Oh, I know how to do that. I'm just going to go 110 plus 10, 120 yards, right? Or it might ask you, what is the tolerance? Oh, no problem, 10. So this actually helps you for basically anything to do with tolerance. This is your recipe, okay, guys? Recipe for success is get it here. Get it, have it break it down into these components, and then the rest kind of follows from that. Let's answer these questions here. Look at my camera work, eh? Which of the following soccer fields would be considered an official field? We know that the maximum the field can measure is 120 and the minimum is 110. So anything that is outside of that is not going to be acceptable. So 109, does it pass? It fails, right? Because 109 is right here, too short. 110, that's good, you're right on the line. 120, that's also okay, you're right on the line. 121, fails, right? So you got to watch out. You got to know how to do those. There are some examples where the numbers are really small, so you're going to have to be really careful with your place values. Come with me. I'm going to do more than just this today, but I want you to go from 41, watch this, from 41 all the way to 43. Okay, 43 has just one question up top. There are two questions that don't have a zero, like a -0 or a +0, but you should still be able to do it if you follow my format, right? My lesson. Okay, so let's do this. Once you're done this, you go ahead and go on your phone, but first let's finish this, right? I don't give you a whole lot of class time to do work, but I'm giving you this today so you're ready for tolerance, because I will AC you on this tomorrow before we do our mock quiz, okay? So go ahead, 41 to 43, and I will give you the answers. If you're done, you should have finished anything between 20 and 24, but if you're done this by any chance and you want to go back and check that, you do that as well, okay? So I'm going to pause here, you go for it. So just because I will ask you at least one question like this on the test, I thought I'd at least give you enough examples. This is on page 44. So you know what to say and how to say it. You can use your own words. On page 44, common examples where tolerance is being applied, right? Keywords would be too large and too small, or too big, too small, right? So how would tolerance be applied in the following scenario? So when it comes to medication, right? If it's too low, if the dosage is too low, it would make it ineffective. It would make it ineffective. Too much, right? If it's too much or too high, right? If the dosage is too high, it could cause an overdose. It could be serious side effects, you name it, right? So let's say talk about an entrance door, a door is being made, right? If it's too small, it would cause drafts, right? If it's too large, it would make it impossible to close the door. I think we already talked about that one, so that one isn't really new to you. T-shirt, if it's too loose, right, too big, then it would be uncomfortable. If it's too tight, obviously it just wouldn't fit, right? A battery, tolerance, how would you talk about tolerance when it comes to a battery? If it's too low, if the voltage is too low, right, the device would not work. Wouldn't work, right? Comma, if it's too high, what would happen? It would fry, right? It would damage the device. So this is where you write your heart out, right? You just tell me that you understand that something happens if it's too little or too low or not or too small. Something would happen if it's too large, right? Or too much. A fridge, if the temperature, I'm just going to summarize, if temp is too low, right? Food would freeze, right? If temperature is too high, food would spoil, right? So that's how you apply the concept of that's good enough. You have enough examples. Speeding, I was gonna say, if you drive too slow, you actually disrupt the flow of traffic, right? Like I don't know if Manitoba, but I know that in some places you get a ticket for driving too slow. I thought that I talked to a police officer that in Manitoba, you know, these bikes, the bicycles that they turn into a motorcycle, they just put like a little kit on it and has a motor. Have you seen those? If they go on a highway, they actually get a ticket because you're going too slow because they can only go like 30, 40 clicks an hour, right? If it's too fast, now you're endangering the safety of people that are on the highway, right? So same idea applies to many, many aspects. So I just thought, you know, if you wanna score marks on a question like this, that is what I'm looking for. What happens if it's not if it's too little? What happens if it's too much, right?